So you made it through chapter 5A, which is the start of this trig identity stuff, maybe with by the skin of your teeth, who knows. But today, like what we're doing in this next part of this chapter, it's originally like one chapter, chapter 5, but the chapter, like the first part of it is all using identities and proving identities and verifications of it. But this section is actually like more of an application of those identities. So it's not necessarily, like we do have a few verifications that go along with it, but it's not as crazy as last chapter, in that like most of the things that we do is we like actually find values, and we're now dealing with numbers again. We have to go back to the unit circle, and we have to remember our values at like a 30-degree angle and a 60-degree angle, and so on and so forth. So we're going to be dealing with degrees today, and then eventually we'll go on to radians, so you can remember some of those values as well. All that stuff is really important that we did back in chapter 3 and chapter 2 to be successful in this chapter. So first thing that we're going to do is we're going to decide, does the cosine of a plus b, because we're dealing with a sum and difference here, so we're looking at values that are like inside our cosine values or inside our trig values that are getting added together or subtracted. In other words, what this question is really asking is, can we distribute the cosine inside our parentheses? Just like asking, like, can we distribute a 2 outside of our parentheses? Can we distribute a square through our parentheses? So some of those answers are yes and no, and we're trying to decide, is this answer going to be yes or is this answer going to be no? So let's see. This is going to be the cosine. We're trying to decide, is this the cosine of A plus the cosine of B? And to decide whether that's true or not, we're going to look at an illustration. We're going to try to figure out if this is actually something that we can do. So we can break up 90 into two values that would add together to give 90. So let's pick like 30. So I'm going to rewrite 90 as 30 plus 60. But you could pick any two values that you want. So we're trying to decide, is this a cosine of 30 plus the cosine of 60. So again, we're trying to decide, is this true? Can we rewrite the cosine of 30 plus 60, which is 90, into the cosine of 30 plus the cosine of 60? So remember, 30-degree angles on our unit circle look something like that. Remember, cosine is always our x value on our unit circle, where our hypotenuse is 1, so just a little bit of a review. And then the sine of theta is always our y value. So at a 30-degree angle, now we're dealing with a 30-degree reference triangle, this side length would be 1/2, this side length would be root 3 over 2. At a 60-degree reference angle, I'll draw actually a new picture so we can look at that a little bit better. So it looks like this. 60. In a 60-degree reference triangle, across from our value here is going to be root 3 over 2. This is a 30-degree angle, so this value is going to be 1/2. The cosine of 30 plus 60 is the cosine of 90 degrees, and 90 degrees is up here. Well, that value, remember, is 0, 1. So that value is actually 0. Cosine of 90. So is 0 equal to root 3? We can combine that into, since it has a common denominator, root 3 plus 1 over 2? Definitely not. So these things, you can't distribute the cosine like that. But there is a way to actually find out the cosine of A plus the cosine of B. There are identities for that, and they look a little bit complicated, and so I'll tell you right now, it's not something that you have to memorize, but you do need to know, and you know how to apply these identities. So actually, since we can't distribute that, there's actually a different way that we can go about that. The cosine of A works out to be actually the cosine of A times the cosine of B minus sine A times sine B. where A and B, remember, are particular angles. So this would be like 30 degrees and 60 degrees. It'd be the cosine of 30 times the cosine of 60 minus the sine of 30 times the sine of 60. And then we can subtract, we have identity for the difference as well. It'd be the cosine of A times the cosine of B plus the sine A sine B. Now, if we're dealing with values that actually have an exact answer, so if two angles have an exact trig value, their sum or difference can be defined as some exact trigonometric value, which means, in other words, if we're dealing with stuff on the unit circle, you need to actually find a real answer, an exact answer like this, versus some decimal approximation. You can't just plug it into your calculator. We can't just evaluate these things. We have to see if there is any way that we can kind of play around with these numbers a little bit to come up with things that we know, and then see if there's a value on our, if we can find an exact value on our function. So what I mean by that is we're going to find the exact values of both these things. So that means that we can break our 75 or our negative 105 down into two different angles that we know appear on our unit circle, two different 30, 60, 45 degree angles that would work. So 75, I can break that down into 30 and 45. And this would then be my A and this would be my B. So my angle of 30 degrees and my angle of 45 degrees. So since I'm adding these two, I'm going to use the sum formula. So I need the cosine of A times the cosine of B. I'm going to start there, and then I'm going to replace the values I know. Sine A, sine B. And we're saying that since it's 30 plus 45, or 45 plus 30, it doesn't have to be in that exact order, our A value is 30, our B value is 45. Again, our A value is 30, and our B value is 45. So we need to figure out what the cosine of 30 degrees is, what the cosine of 45 degrees is, what the sine of 30 degrees is, and what the sine of 45 degrees is. So that means that we're dealing with like two reference triangles, basically. One is a 30-degree angle reference triangle, and the other one is a 45-degree reference triangle. So this is good review for you to go back to that. So this is the 30-degree one, and then this is the 45. So if I deal with this triangle first, this would be my sine value of 1/2, and then my cosine value is root 3 over 2. So that means the cosine of 30 degrees is root 3 over 2. And the cosine of 45, remember 45-degree angles have root 2 over 2. The sine of 30, my y value is 1/2. And the sine of 45 is root 2 over 2. So as we simplify, this first one, when we multiply, these fractions are going to multiply, so we would just multiply across. When we multiply these, we get root 6. We just multiply the inside of our radicals over 4, minus, multiply across, we get root 2 over 4. So altogether, we can write that as one fraction, since it has a common denominator, as of root 6 minus root 2 all over 4. So just because we have a calculator, I want to see if this actually does work. So in your calculator, let's find a decimal approximation for this, just so we can check to see if we did our math correctly. So we'd have root 6 minus root 2, and then divided by 4. So we get a decimal approximation of 0.258819, and so on and so forth. And I can find then a value of that in our calculator. Let me just double check, make sure I'm in degree mode. So I'm going to do cosine of 75 degrees, and there we go. We get the exact value of the 0.258819, and so on and so forth. So yeah, we did our calculation right. We get our exact value of the cosine of 75 degrees. Which is kind of cool that even though this isn't on our unit circle, we can break it apart into things that are on our unit circle, and we can come up with an exact value. Okay, so I want you to pause right now, and I want you to see if you can come up with two values that would add up to negative 105 degrees. So hopefully you played around a little bit. The values that I came up with are, since it's negative, you have to be a little bit careful, but I came up with negative 60 and negative 45. And it doesn't actually matter if you represent it as negative 60 minus 45 or negative 60 plus negative 45. Both of those represent the same thing. It just depends on if you're going to use the sum or difference formula or not. So this one, you would use the sum identity. And this one, you would use the difference identity. I spelled that wrong. Your A value would be negative, if you're going to use the difference, which I'm going to show you that one because it's a little bit harder in this case. Your A value would be negative 60. And your B value, and here, since you're subtracting your B value would be the 45 degrees. If you used the sum identity, your A value would be negative 60 and your B value would be negative 45. So you actually never have to know the sum and difference. Like, you could always just use your sum and just add on a negative. It's up to you, of your preference, whether you want to do it that way or not. But I'm using the difference identity just because we use the sum identity over here, and so it's a little bit different. So our A value is negative 60 and our B value is 45. So again, I'm going to write out our formula. So we're starting here, which is pretty much the same thing, except we have a plus here instead of a minus. And we're looking at the cosine of negative 60, the cosine of 45, plus the sine of negative 60 and the sine of 45. So right away, I'm going to do these ones first because those ones are nice and easy. I already know the cosine of 45 degrees is root 2 over 2, and I know the sine of 45 degrees is root 2 over 2 too. So I don't have to deal with that too much. I'm not even going to draw a reference triangle for that, but I will do it for the negative 60. So negative 60 means we are going, instead of counterclockwise around our unit circle, we're going to go clockwise around our unit circle. And so we're down here in quadrant 4 with a 60-degree reference triangle, reference angle. In other words, negative 60 is the same thing as 300 degrees. So this value across from my 60 degrees is negative root 3 over 2. Be careful because we're in a different quadrant, so we have to be a little bit careful about our negatives and our positives. And then our cosine value is going to be positive. So when we evaluate this part, our cosine again is positive 1/2, but our sine value is negative root 3 over 2. So again, the only difference between our sum and our difference is that this would be a negative here, and then that would be a, like, you would have a minus like that, and then this would be a positive value. So it works out to be the same as like plus a negative or minus a positive, and like that's the only difference inside then when you actually evaluate your functions. And we multiply across, so we'll get root 2 over 4 and then negative root 6 over 4. So we get a value of negative 2 minus root 6 over 4. You'll see that like when we do these enough and we are dealing with like 30, 60, 90 triangles all the time, that these values, the root 2 and root 6, are really, really common because we end up like multiplying root 3 times root 2 a lot, or we have this denominator of 1/2 and root 3 over 2, or if we're dealing with like some things with tangent, we have root 3 over 3, and so there's like, since we are dealing with the same values over and over again, just different combinations of them, these values of root 2 and root 6 come up a lot. And again, we can double check in our calculators. We get the cosine of negative 105, we get this. Oops. Let's just double check. And we get the same answer. So that's kind of nice about this unit, is that you can always check to make sure that your value actually matches what it would be if you evaluated. And that allows you to double check negatives, because if you did forget that this was like a negative root 3 over 2, then you can go back and be like, okay, I must have missed a negative somewhere. Where did I miss that negative in my unit circle? Okay. So we're going to do a couple more. This top part here is actually like working in reverse. So we're matching up our sum and difference identities from the front side and looking how we can find this answer finding the exact answer given this. So let's see what this one looks like. So we're dealing with cosine of something, sine of something, sine of something. And inside we have a minus. So that one really does match up with the sum identity here. So this would be our sum of cosine of a plus b, because that's what it matches up with. This would be your a value, this would be your b value. So we can find then what an 87 plus 93 is, because this is really equal to that, since it's really the sum identity. If we did write it this way and then broke it up like we did in the front side, this is what we would get. And if we do that, 87 plus 93 is 180 degrees. And then that will work out to be an exact value, cosine of 180 degrees. That's 180 degree angle over here. Our cosine value, or x value, is -1. And again, we don't have to use a calculator for this, because we did it obviously by hand, but we can always type this stuff into our calculator and see if we do get the value that we wanted to. Oops, sine of 93, and yep, there we go, we get -1. So some of your ones I've practiced kind of look like this, where you're working in reverse and you're matching up the identity, and some of them you're going forward and you're using and applying the identity.